The domain of a function is all the possible sets of x values. It can be represented by x element of R, and the range of a function is all the possible sets of y values, as it could be represented by y element of R. Before we start talking about domain and range and the ways to write it, I feel like we should go through some things that you should know beforehand. The difference between the normal brackets that you use, which is just like this, the curvy brackets, and the difference between the square brackets are very different. When you use the square brackets, the ones right here, it signifies that the point is included. If you use the normal brackets that people use, it signifies that the point is excluded. Another thing is the difference between a filled point and a empty point. A filled point shows that the point is included, and the empty point shows that the point is excluded. There are multiple ways of writing the domain and range of a function. You could write it in the way of x element of R, such that x is greater than 7 or less than 8. Along these lines, I feel like this way of writing domain and range may confuse people for people who are new to domain and range, so I'll write it in the more commonly used way, which is the coordinate way. So it could be, could be negative infinity to infinity. I feel like this way of writing it is a lot less confusing. Something else that you should know is the domain for a quadratic. Any quadratic that is not shifted, obviously, any quadratic will always be x element of R. Will always be x element of R. This means that the domain is all the possible sets of x values. Every x value is possible. As you can see, it goes to the left to infinity, and it goes to the right to infinity. So all the x values are possible. But for the range, it is definitely limited because it has a height that is limited. So as you can see, it's limited right here. That is the limited range. But then the height of the range is infinity also. And the domain and range of a linear term, which is simply just a line. So let's use this line right here. It is infinity it is x element of R and y element of R, because it could go to infinity this way, this way, this way, and this way. So that is why people don't really find the domain and range of a linear term, as it is basically useless. In all terms, it is always going to be x element of R and y element of R. Alright, let's start off with some examples and move on from there. We have the example 1 right here and the example 2. Let's start off with the example 1 and work from there. Alright, so the example 1 is this line right here. Make sure that you realize that this dot is filled and this dot is not filled. Alright, so the domain for this function is represented as all the possible x values. So let's draw a dotted line for all the possible x values. The lowest x value is right here, and the highest x value is right here. Let me get rid of this. It's right here. It lines up with 1. So the lowest is a negative 1, 2, 3, 4, 5, 6, 7. So the domain would be from, remember, you use the square bracket because it is including that point. So negative 7 to, it goes all the way to 1, as you can see right here. Let me use a different color. It goes all the way to 1. Goes all the way to 1. So negative 7 to 1. And you use the bracket because it is a open point. So that is the domain. Now let's move on to the range. By the way, you could always write it as d with a subscript of x to signify that it is all the possible sets of x values, or you could just simply use the d and r. Alright. Now let's move on to the range. The lowest set of y value would be right here, lines up right there, and the highest would be right there, lines up right there. So the lowest is negative 1, 2, 3, 4. There's negative 4. And the highest is 1, 2, 3, 4, 5. So it is including negative 4, so we use the square bracket, including negative 4 and excluding 5, so 5 with the circle bracket. So this is the domain and range for the first function. Now let's move on to the second function. Alright, the second function only has one dot, and it is closed just like this one. It's right here, closed, and it goes on to infinity as shown right here. It goes on to infinity. Alright, so now let's start off with the domain. The domain is, the lowest is at 1, 2, 3. So start off with the domain. Actually, let me use a different color. The domain, the lowest, is a square bracket because it is including that. The lowest is at 3. And as you can see right here, it goes on to infinity because it goes right here. So that means it goes this way and this way to infinity. So you could write it as infinity. And the range, the lowest set of y values would be from 1 right here, as you can see. So it goes from 1 to infinity because it goes all the way up to infinity. It goes to the right and to up as infinity because it goes in a diagonal way, like just like that. So you could write it as infinity. Alright, let me clear up some space to show you the answers and make it a little more clear. There's a lot of arrows going on. Alright, as you can see for the first function, let's go back to the first function, the one in red. The domain is negative 7 included, comma 1. That it go all, as you can see, all the values are possible right here. So let's say between negative 7 and 1, let's call a 0, right? There is a 0 right here. Oh, oops, my bad. There is a 0 right here. Now let's say a negative 4. Let's see, negative 1, 2, 3, 4. That is possible right here, just about right there. So as you can see, all the possible sets between negative 7 and 1 exist. And for the range is negative 4 to 5, which just about makes sense. Negative 4 to 5. And for the second function, it is a little different. As you can see, it goes to infinity on both ways. So it goes up to infinity and to the right to infinity. Therefore, oh, I didn't even close the bracket, my bad. Therefore, the highest value of the domain and the range is to infinity, and the lowest is, as you can see for the domain, the x value is 3 right here, and the lowest for the range, which is the y value, is 1. Alright, that's some basic information about domain and range. What we went through in this video is that the domain is all the possible sets of x values, the x values. As you can see, we use the domain with the subscript of x, and the range is all the possible sets of y values. So you could put a subscript of y. Something you should know is the difference between a filled in dot and a open dot. The filled in dot, we went through this in the beginning of the video. The filled in dot means the point is included, and the filled the hollow dot, the one that is not filled, it shows that the point is excluded. The difference between the brackets signify which type of dot you have at hand. So as you can see right here, we used the circular bracket, unlike these ones, the square bracket. We use the circular ones to show that this point right here is excluded. And the domain for a quadratic will always be x element of R. That means all the possible sets of x values exist. And the domain and the range for a linear function, which is simply a function that only has an x term, not an x squared, because that would make it a quadratic function. A linear function always has x element of R and y element of R. That is why it is kind of pointless to find the domain and range of a linear term. Alright, thanks for watching.